Hello and welcome. My name is Nick Rambo, and I am the Director of Graduate Recruiting here at the Mitchell E. Daniels Jr. School of Business at Purdue University. I'm thrilled you're joining us for this session. Today, we hope to really dive into the world of robotics to understand how failures and challenges within that sector can really inform the business side of operations and how that's going to relate to our MBT program, which is brand new here at Purdue. I'm joined by a couple of fantastic panelists today. I'd like to introduce them to you now. First is Patrick Hyun. He is an assistant professor in electrical and computer engineering here at Purdue University. His research focuses on control theoretic aspects of bio-inspired robots, emphasizing systems with extreme behaviors such as flapping vehicles and impulsive systems. He was formerly a research associate at the Harvard Microbiotics Laboratory and received a PhD and 2 MS degrees from Georgia Tech. Patrick, thanks so much for joining us today. We're thrilled you're here.
Yep. Thank you for the introduction, Nick. Yep.
Absolutely.
Nice to meet you, everyone. Yep.
Thanks. We're also joined by Professor Mohammed Rahman, who is the inaugural Daniels School Chair in Management and a professor here at the Mitchell E. Daniels Jr. School of Business. He was named one of the world's top 40 business school professors under 40 by Poets and Quants, and his research and teaching interests primarily focus on omnichannel retailing, innovations and inequality, AI and decision-making, data-driven decisions in digital business, and digital transformations in markets. Mohammed, thanks so much for joining us this morning.
Thank you, Nick. Thanks for the introduction. Hi, everybody.
Perfect. Well, excellent. Well, as we get into today's content, Patrick, I'm wondering if you can kind of walk us through briefly what exactly the control theoretic aspects of bio-inspired robots is. Can you kind of, boil that down simply?
Yeah, so it's basically it's a long term, but I'm very interested in the locomotions of animals. For example, like birds. So here's like one example that the robot that I'm working with, it's like a flapping robot. So you guys may have seen a lot of like drones, which is quite artificial in my terms, because it's not like nothing like an animal has this kind of fixed rotor to fly around. So, but looking at the evolution of the animals, I mean, they tend to choose the flapping mechanism. And I started like the questions that why like the man-made system does not really exploit the feature of the flapping. And there are a lot of that's just one example of the bio-inspired for the flapping vehicles. But there are many kind of bio-inspired kind of robots, like walking robots, right? It's like sometimes some people make a snake robots too. So these are something we call the bio-inspired, meaning that we inspire from the nature and to learn about their kind of ability and how well they outperform, or maybe like what's the benefits of having those kind of systems. And especially I'm focusing on the more mathematical sides of describing its kind of emotions and how to control such as systems.
That's really fascinating, and I'm sure that will kind of play into the rest of our discussion today. But as we're talking about robots, right, which is really exciting, and there are lots of sort of movie references that you can go to. But I'm curious if you can kind of talk about the evolution of robots, maybe in terms of your experience with them, or even just broadly over the course of however long it is that we've known about robots.
Yeah, so it will be a whole lecture to go over the whole evolutions of robots, but I think it might be best for just general audience to think about, we use the term robot a lot, but what is the robot, right? Like how we classify the robot. I think that's like could be the first question to ask. So the word robot actually was introduced by the playwright named Karl Čapek from the Czech in 1921. So meaning that it's actually something fictional thing. So the definition of robot back then was like more kind of a forced labor that helped the masters to do some work for you. So in a lot of ways, that robot is something that was originally designed to help people, right? To make it ease of their task, or maybe do it better, right? So if we just do a very layman kind of approach of, if I don't know about the robot, you have to search online, or maybe the dictionary. So if you look at the dictionary, what does the robot says, and that kind of have all the kind of important features of what robot is and how it evolves. So if you look on the dictionary, like Cambridge Dictionary, then it says mechanical device that works automatically or by computer control. So I think the big keyword is automatically, right? So we need some kind of a machinery that actually move automatically, meaning that I don't need human input anymore, so you move automatically. But in Collins, that it says that a robot is a machine that is programmed to move and perform certain tests automatically. So the keyword here, I mean, here it has automatically, but it also has programmed, right? So at the evolution actually happening to actually have the system that can be programmed to do some tests automatically, right? So the programmed and programming and the automatic feature is very important. But I really like this Merriam-Webster definition of robot, which is a machine that resembles a living creature. I think that's very strong opinion. It does not have to resemble the human shape or the animal shape, right? There are like whole tons of robots. So let me continue. A machine that resembles a living creature and being capable of moving independently. So I think the capable of moving independently is, I think, something also very important, such that once we program something to move automatically, it should do the job by itself, meaning that it should actually perform the task independently. So all these kind of three keywords of the programmable autonomy and this kind of independent ability to move really evolved the field of robotics. And I can give you some of the types of the robots in past if you are interested.
Yeah, that's actually a great kind of transition point for us as we think about, how we apply, understandings in robotics and some of the failures that we've experienced there, and what that, how that informs us in the world of business. So talk us through some of the different types of robots that are impacting business today, and really, fundamentally what we can learn from that evolution, right? That progress, that, because it started with a very fundamental idea, right? It's something that did something for you, right? So how does that, how does that play into where we are today in the world of business?
Yeah, exactly. I think the failure is definitely, as the title of this webinar, I mean, it's a very important feature because it seems like you learn the maximum by not knowing things, by learning the things that you don't know, right? So that's the start of the basically you're being better, or you actually learn or expand your knowledge base, right? So to do that, I think robot is a good platform to start with because we can do experiments just like any scientists do or engineers do. And there are many different types of robots that has evolved, but if I may have to, let's say, categorize or give some of the example, I think the very first most one was the robotic manipulator arm. I mean, you can actually pick and place, but it's more kind of stationary. So, and then it gives kind of repetitive kind of tests doing more kind of successful actions. So there's not many risks. Or maybe failure is that maybe I grabbed something and I dropped it, but maybe you can really pick it up again and then go, right? But the question is, you need to need to learn about this, something called the kinematics. Like how can I get there? What type of robot configuration that I can make sure that I can pick up this Amazon box, pick it up, and then put it to the other side, right? So the robotic manipulator is actually was basically the key thing to be like the beginning of this whole robotics business. And many kind of successful kind of stories are out there. Just factory is just one example, but also like the teleoperating kind of surgical robots too. So that it's not just about like the business that actually helped maybe the factory to run, but also it really helps the humans. It really helps actually how to advance the technology to give a better service in the medical field. And recently, I think there was one of the annual biggest robotics conference just happened in May, and then I think one of the company in Japan, they kind of showcase their kind of a tiny micro surgical robots that teleoperated, and that actually kind of stitched one kernel of the coin, and that was actually quite amazing using all the 4K kind of cameras, and then the human expert was actually doing it, but because of the high precision, what robot can do, which actually give you the best results. So that's one, which is a robotic manipulator arms. But there's another one, which is something called the wheeled mobile robots. Wheeled mobile robots were used a lot. And I think many of you actually have seen it or have it at home. So there's not many kind of successful story, in my opinion, at least, that robot actually get into the house or make people to buy or make people to use it more frequently. But this cleaning robot is actually have a really good successful story that people doesn't really feel kind of foreign that this kind of a device is at home because it does the job pretty nicely. But the task was actually simpler, and it's actually not at the catastrophe when it fails, right? compared to the surgical robots. We need high precisions, and there are a lot of like a conservative point of view must be taken for a surgical robot business compared to the like the cleaning or the house the appliances. So so those kind of robots are actually move around with the wheels. So that's what we call wheeled mobile robots. But also there are something called the locomotive robots. And also many of you have seen in the news, like the Boston Dynamics, like the Atlas, like showing fantastic where it dances with the other, there's something called the dogs. And most recently it kind of throw the tools, like the heavy tools, and pass it to the human. So it's kind of having an interaction with actual human, and it looks like human too, right? It has two arms, two legs. I mean, robot does not have to have two arms, right? It could have like 8 arms, right? Like, I mean, it doesn't have to, but it just chosen to be a human form. So there are kind of so the whole story of the Boston Dynamics is actually the legend of how it evolves. And then another thing is that the flying robots, which we call in, I think in research with terms unmanned aerial vehicle, because it's not like human is not in there. So unmanned aerial vehicle like the drones are actually really big, and it's relatively easier to control and robustly. So it has many uses. But the one more category that I wanted to mention, or another examples of the different types of robot, is actually wearable robots. People study that a lot. I mean, it's not just that I just wanted to put the robots in the factory, put the robots to by itself, but we do want it to interact, but interact in actually a more physical way, a closer way, and a help to people who actually need to actually have more muscles, for example. So like a prosthetic devices is also part of the wearable robots, I would say. And also there's like a lot of people work on the exosuit as well. So these whole kind of the evolution or different types of the robots at each type actually shows that our society actually needs some of these kind of the devices that maybe actually we need to move forward to it. And that's kind of some of the brief summary of some types of robot. I didn't cover everything, but those are the things that, I think that's quite impactful.
That's fantastic. And again, I'm just seeing like Iron Man, I'm just seeing all the movie references and what you're talking about, exosuits and bionic sort of, arms and things. But I want to circle back to where the focus of today's webinar exists, and that's kind of in that failure, right? You talked about some of those early discoveries within robotics, right? You've got 2 arms and 2 legs. There's obviously the famous video now on YouTube of robots, falling over and crashing and burning, right? So you've seen some of those things. So I'm curious, as we think about failure and how we've progressed forward within the field of robotics, what are some challenges that are still present today in your field?
Yeah, so I think that's a great question. The failure is an interesting question, isn't it? I mean, because if everything is controlled, if I have to choose like one out of 2 things, then failure means I choose the another, right? So it's kind of like a 50-50 chances, right? But if I have more choices, for example, then there are many options they're more likelihood to be failed, right? But as we say in the definition of robot, we want to have the robot to complete the task what we want it, right? So somehow, in some sense, that we don't want the failure, right? We don't want when it executed, we don't want the failure. But the thing is that the choices will be a lot in general, meaning that if robot actually deployed to do something for the unknown environments, so there are a lot of kind of uncertainty out there. So the biggest challenge I think these days in robotics is how to deal with this environmental uncertainties. That environmental uncertainty contains a lot of things, right? For the flying robots, like the drones, some gust of winds or some change of the, let's say, but what if it rains, right? What if the strong wind blows? Like, how can you still do the job that what you want? Or for example, like a surgical robots, right? Like if you go out by like 2 millimeters, that could be really critical conditions, right? But then if the patient breathes and then it moves, right? Then I mean, how are you going to deal with that situation? So there are a lot of situations that the challenge comes from something that's external, but also some of the internal type of challenges are the dynamics, what we call is actually quite complex. So if we think about the simple arm, I have shoulders, I have like, elbows, and I have a wrist. This is pretty simple. What about this? Can we make a robotic hands finger to do like this? And how do we gonna the control everything what we touch with our fingers, not how human can do? So naturally, I think that as the robot gets more evolved and we want more functions to it, it becomes more complex. The complex in dynamics, meaning that it's as for me, like a mathematicians and roboticists, it's actually a very hard problem to solve, hard problem to find a control as well. So there are these type of the challenge that I introduce is what I see is actually as an opportunity, right? Because I mean, because of those failure, we kind of think about, okay, do we need to accept the failure? Do we need to reject all those kind of possibilities? Is that what our control should go? Or in more a sense that maybe the failure is fine. Maybe I just keep do it again and again and again, and I actually keep learning how to control, right? So that's these days, like the many people are looking into this uncertainty as more like as an opportunity, and these type of machine learning or other technology, something in more control, it's something adaptive controller, is actually keep observing this kind of uncomfortable failure constantly to evolve it better to have a more accurate, high precision control in the later terms. And that's the goal.
It sounds to me like you have to keep like failure isn't the end, right? It sounds like that's what
failure
you're saying, right? Failure is just a step in the process. And so with that in mind, and I want to keep our context of the business world sort of at the forefront of this, but as we think about, how challenges are, shaping, the world of robotics, what does the future look like sort of at that intersection of automation, robotics, and business, in your opinion?
Yeah, exactly. So everything here is in my opinion. So the failure, I think it depends, like the failure, right? If the drone hit the tree with its maximum speed, that failure versus it just tumbled a little bit, failure. That he wanted to, let's say the robot wanted to hover, but it tumbled a little bit, right? So those two are very different type of failure. But if you actually, so that's why the solution must be there. If the drone actually hit hard, let's say on the trees, I mean it may broke. So then we can't fly again. But one of the reason why it kind of a break is because it's very rigid, right? But what if robot is like a squishy thing? It's like a squishy, like a what is it called? The slime. My son usually like it. Yeah. So I mean, if the whole body is like compliant, but if you touch your skin is very compliant, right? So when you fall down or when you touch something, you gain a lot of information of this kind of compliance, right? So what I want to say is that there are some mechanical solutions, such that robots and a lot of people are looking into this direction, which is something called soft robotics. How we should make the robots and have this mechanical solution to give the robustness, which is giving the softness of it. So a lot of like a material properties, people are looking into it to maybe replace the conventional motors to some other types of kind of soft muscles. Or so those are mechanical solutions, and also some kind of like more software solution to how to deal with that is basically you need to observe really quickly. You need to observe, you need to sense things fast. How we should advance this kind of sensing technology so that we can get from the perceptions directly to the control. And if you look at the autonomous vehicle, how they're constructed, they put a lot of sensors. So they gather as much as information fast enough so that they make a decision quicker, right? So these kind of those kind of challenges that we expect to happen, which is the failure that expect to happen, can actually teach us how to actually design our control loop, which is the feedback loop, to go directly from perceptions to control in a more faster pace. And that's what these days the robotics kind of control field are shaping. And with this our MBT program in the robotics and automation kind of course listings, and basically we're going to learn fundamental things about how things move mathematically, how things work mathematically, but also it's not just about math, but it has a lot of good kind of applications and examples to actually see how the principle works first before the people who have this degree can actually go out with, that I learn about the robots, right? So that the teaching about the principles.
Patrick, you're doing a great job of doing my job. I love your transition point there.
I tried to connect it there.
Really,
But,
really
yeah.
well done. I appreciate that. I want to shift over here to Mohammed, and I see a lot of potential conversation topics here, but since Patrick brought it up, I do want to get into the meat of, what is the Master of Business and Technology program here at Purdue all about? And I think you're a great person to answer that question.
Yeah, well, thanks. Actually, before I answered that question, when Patrick was talking about robots taking different sort of shapes of things we know, right? Animals. So a quick anecdote, back in the days when I was an undergrad in CS, we had to do a movie for one of my graphics classes. And the idea was, we're going to come up with some aliens robots. And guess what? We actually adopted the shape of spiders. We didn't have to, right? So I think this is a very good point. And so the idea, in MBT is, as we think about, so back then when I did that was more than 20 years ago. It was all sort of a fictional thing. But as we look at today, I was actually reading about it yesterday. So I think Patrick really correctly talked about robots and their abilities and the challenges in sort of consumer adoption. So CNN actually was promoting some mopping robots. They're like $1,800 a piece, the best one from the ones that tested. And then there is another one, I think that's in the price range of about $200 that can mop and also vacuum your floors. Now, when you think about the evolution and as we think about, so there is science behind it, but as we think about these economic impact of these robots, there's a business aspect of it. So you need to sort of think about, okay, at what point, for what sort of consumer preferences or their sort of comforts that we can use these kind of conveniences, we can use these kind of robots. And that requires real deep understanding of the business side of things, as well as the technology side of things. And that's exactly where MBT sits, right? So as we think about the business education and the graduate education for business, the goal here is to really produce skilled employees or leaders, right? Entrepreneurs who can go out there and really manage this world where technology is the central element of any business that you look at, whether you think about logistics, whether you think about manufacturing, right? So these very traditional industries today is very, very much robot or automation oriented. If you want to manage them, you really have to think about the changes. So you have to understand the whole business landscape, but you also have to understand how technological sort of abilities will change the business models. And that's key as we think about consumer acceptance, as we think about marketability, as we think about sort of business aspects of different products that's coming out of automation or robot sort of research or industries. So in a nutshell, MBT is a degree that prepares the next generation of leaders with education, both really on the business side. So you actually understand the whole business fundamentals, making sure the business is running well, their business model changes, but as well as the technological understanding, particularly for anybody who really wants to get into this field. If you don't understand the nuances that Patrick was talking about, you might be making business decisions that don't make any sense. You're going to hit that tree very hard with that drone when you don't want to do that or when you shouldn't be doing that.
Yeah, I want to kind of circle back to that for a moment. You talked about business fundamentals, right? And I think there are a lot of schools out there, that have fine programs, but what they've done is they've really kind of just added on a few supplemental courses to an MBA or something like that. Whereas MBT is something that we designed mostly from the ground up and that we did in collaboration with the College of Engineering and the Computer Science school here at Purdue. So I'm wondering if you can kind of talk about that within the context of, how MBT is going to integrate the technological side that you talked about, and not just like business fundamentals, like as we thought about within the MBA context, but business fundamentals, with a really future-oriented outlook. So if you could talk about that, that'd be great.
Sure, yeah. You're absolutely right, Nick, right? So when you think about everybody is recognizing the trend, it's just natural, right? But most of the schools, almost all actually, just tried to retrofit their programs. We, being sort of as a leading sort of university in innovation and and technology, right, with a great engineering program here, we really took this seriously, and we said, you know what, we got to really do the education in the right way. So if you think about a degree, it should really think about technological product design. That's kind of what goes back to what should the robot look like? What should the robot do? That really goes back to what the consumers' needs are and what the business aspects are. So we need some classes like that. You need really thinking about, okay, what kind of emerging business models we're going to have because of the changes that are coming up, where different technologies fit in, including robots, right? AI, and where the mesh of the two comes in, and I'm going to come back to that. And and when you think about these sensors, these like automated technologies that are in play, they collect a lot of data, right? And there is a lot of concern at that point then about governance and regulations around these things, right? So you can have flying drones doing logistics, which is where many of the retailing world is heading, right? So we're going to see that happening soon. But how do you sort of manage that whole fleet? What does it see as it goes, and what data it collects, and who owns this data, how it's governed, why policy should be different, how companies should be responding to different policies? You need to learn all of that. And so if you do the hodgepodge of retrofitting a program, you're not going to have that thought process, right? So that's the difference in MBT. We have that. So I think, like, and we have different tracks, but they're gonna sort of like, if you think of robotics and automation, if you think about products that are going into the homes, and I think Patrick was saying, he doesn't feel like it's made that much inroad. I agree. But a part of this is like, we cannot have a conversation. But as we see large language models evolving and the capabilities evolving, now you can actually tell a robot, hey, give me that part, and it might throw that part to you, right? And have that natural conversation. And I think so these are capabilities a business leader would need to understand. Even if you're going to be really an engineer who is working in the engineering team of automation, you still need to understand the business side of things to really make sure the products and the capability they develop overall adds to the bottom line and the functionality of the business. So that's where this program is actually developed with the idea in mind, and this whole close working collaboration with engineering and business school is because of that.
That's a great point, and I'm going to circle back to Patrick here because within the construct of MBT, there's the business core, and then we actually have 4 different elective tracks or concentration tracks, excuse me, one of which is robotics and automation, which is why Patrick's here. So Patrick, I know you're actually teaching one of our concentration area courses. So I'm curious kind of, what are the outcomes within your course, and how do they apply to what we're talking about in this, very transformational, disruptive, technological invasion, right, of business?
Yeah, so my course that I teach in the fall semester, which is EC 569, that's a course about introduction to robotic systems. So that course were designed to such that it was actually meant for the person who actually have the backgrounds in engineering, because we do a lot of math. But what are the math used for, let's say in the business term, or not just for business, but just in a more higher impact, right? So we're going to learn about more kind of fundamental things about manipulators. So because that's the start of everything. So from there, once you learn that, I think one is that you learn how things work, basically. Because if you think about if you know the manipulator, and that's actually the walking robots too. Walking robot the legs can be viewed as a manipulator as well, right? So it kind of learn about the whole principle of once you have the robots that, let's say, you want to sell, you understand about the challenges, understand about what's basically good to have, what type of good configurations or good form of the robot is, because there's a lot of business questions are there, because it need a sensor, it need an actuator. How many actuators you need, how many sensors you need. So there's kind of like a cost kind of the efficient questions are there, and that related to what's possible with this robot or not. So business model can be actually start from the needs to define why we want this to do it. But this course will be on the other side of the track, which is how can we actually do it? What's the first principle of it? So taking the courses and maybe in the business program, which is the top-down level, versus this kind of automatic robotics automation is more you're learning from the first principle. So at the end of the 2 years or 1 years, I think there is a middle points that you're going to meet, so that this kind of whole training will definitely be connected at the end of the day. Is my opinion. Yeah.
Yeah,
that's great.
actually, I'm gonna seize on what Patrick just said, right? So I think the key here is this. So just consider yourself working, or you don't have to even think about working. Just think about Amazon, think about Walmart, right? And think about the logistics management or the manufacturing management of any of these companies. Everybody knows, or actually better yet, think of Pizza Hut, whose kitchen is pretty much now automated. So if you're working for any of these farms and you want to be sort of climbing up in the management positions, whether on the engineering side or more on the business side, just for a second, just think about plain vanilla MBA business side, right? You want to get a job and think about the sort of the high level C-suite perspective. Do I put in a manager who just understands simple finance and accounting, and so the MBA sides, which we're covering anyways in MBT, and some probably like more deeper sort of understanding of like marketing and negotiations. So like the plain vanilla MBA who has the more people-oriented training, we put that person in sort of managing my overall sort of management of logistics where I have a lot of robots, or do I put somebody who actually understands all of that stuff or more, like really well, plus somebody understands, what the capabilities of what my robots would be able to do in my plant or on my floor, right? Or, what my robots would be able to do, where can I see the possibilities that they might break down? You may not be the expert who actually does that, all of that, but you have to be the one who would understand the possibilities with it, right? Investment sort of opportunities. If you're going to be automating the whole kitchen, what are the things this kitchen is going to look like? If you don't take that class that, like Patrick really talked about, you don't understand all the nuances that are risked involved in that sort of investment decision. And naturally, this is where the world is heading. And that's why this marriage has to happen in the education.
Yeah, I think you're spot on there. I think as we talk about automation and robotics and the role that that's playing now and will continue to play in the future, you're seeing things like automation, obviously, but obviously optimization. I think it's a big part of it. Like, it's not just about getting the job done, for these major corporations, like we're talking about Amazon and Pizza Hut and Walmart, they're trying to, become more efficient in their processes. And so I think it's going to take a new wave of leaders who understands the technology and the business side to really, again, optimize to enhance some of those outcomes. And speaking of outcomes, Mohammed, kind of in our final thought here in this section, I wanted you to kind of walk us through, MBT being new, being a novel sort of concept at many universities. We understand that, right? But as we think about the future, we feel like our degree, this MBT, is really well positioned to equip graduates for success. But I'm sure some of our listeners are going to want to know, where will that success be? So can you walk us through kind of some of the general expectations in terms of outcomes, what roles and positions people that graduate from this degree are going to be well qualified for, going to be well prepared for?
Sure, yeah, definitely. So, like if you think about generally as the program itself, right? So there is a lot of jobs now in product management, product managers, right? And that product manager job is in many flavors, including robotics. There is sort of AI products, there is digital sort of experience products, right? So we were talking about cars earlier, right? So even cars today is all about experience, no longer about just a car moving, right? So I think there is a lot of that. There is a lot of jobs as analyst, business analyst, or and there is a fair amount of job in technology sector, right? So if you're an engineer coming into this program, you would be probably still sort of working in some engineering job, but more of like project manager, and then becoming sort of like the more of the product owner and that path, if you still like to do that kind of job, right? Because if you're just an engineer and you're training engineering and you don't understand the business side of things, it's hard to actually climb up the ladder. Because at the end of the day, you have to argue why your contributions are actually making sense in the overall business perspective. So I think the opportunities are there. And then if you want to be in finance, if you want to be in like I guess pharmaceutical industry, you want to be in manufacturing, every industry today is all transformed. So industry doesn't matter. Whatever industry you want to be in, you can find a job in these kind of roles.
Fantastic. Thanks so much, Mohammed. Patrick, I want to shift back to you for a moment. Any sort of parting thoughts for our listeners today?
Well, I think I agree with what Mohammed said about the needs, and then like a type of different person out of this program. Like, what if you learn about this kind of a more technology kind of a knowledge basis? So I think that's something. Just looking at in terms of the programs that we have at the MBT here, robotics and automations, and I mean I think some of the course could be like review, if you take the course, not seeing that big picture in the very first few weeks, but at the end of the day, what you learn is basically speaking the language and seeing actually what's actually the limitations, like, because I mean they will kind of come to you that like this doesn't work, this will work, right? But the reasoning behind that, what's the limitations of the kind of like this kind of classroom examples of how things work, we're gonna shape that like in the future, like what's actually within the business model or in the advanced technology, what will be the limiting factor that has to be be considered to make a big decision to go or not go, right? So because like for example, like in the like Tesla or like these kind of big companies are kind of leading the directions in a way, right? But there are kind of fundamental limits. What is actually present there, and I think throughout these courses, I think the biggest thing is that the speaking the language and seeing from the first principle what is the limitations. So that's from my side, the last point.
Excellent. Well, thank you so much, Patrick, for your assistance today and your expertise in this area.
Thank you. Yeah.
Yeah, I also wanted to take a moment to introduce my friend and colleague, Jennifer Krupa, who's on the call today. Jennifer is currently leading our efforts for MBT recruiting. We are currently enrolling for our next cohort. So if you would like to get in touch with her to ask any specific questions about the robotics and automation area or other potential concentrations, Jen, what's the best way that students can get in touch with you?
Yes, thanks, Nick. So I just dropped a link in the chat that is directly to allow you to schedule an appointment, as Nick mentioned, to discuss any details about the program. If you want to get more deeply into your background and how that might fit for you with the MBT program, feel free absolutely to schedule an appointment with me. If you're looking at applying, that's another great thing to do, as well as we can discuss any elements of the application and deadlines.
Excellent. Thank you so much, Jen. Appreciate your time. Mohammed, any parting thoughts for our listeners today?
Well, I think, if you are thinking about, I mean, an MBA that prepares you for the technology world, so a lot of these people are sort of, I think what's now in the tech MBA sort of world, right? That's where the world is heading. That's kind of degree we need. I think we can confidently say that there is pretty much not any other school where you can find that there is this kind of real opportunity to get relevant business education and also the technical education, right, with the appropriate background from engineering. I think this is a once in a lifetime opportunity for people.
Excellent. Well, thanks so much for your time as well. On behalf of all of our panelists here and everyone here at the Mitchell E. Daniels Jr. School of Business and Purdue University at large, again, we want to thank you for checking this out, and we hope to engage with you more in terms of how MBT can really, kind of reshape your future. So from all of us to all of you, boiler up.